Hi, fifth graders. In our last video, we talked about how to divide by both a whole number and a decimal divisor. But you might have noticed that all of the examples in the last video didn't include remainders. That's because today we're going to talk all about how to divide without having a remainder. In other words, from now on, you're going to turn your remainder into a decimal value instead of writing R5 or whatever your remainder is. So to do that, we will need to add zeros to the right of the last digit in the dividend. So remember, we can do this because adding a zero on the right does not change the value of the dividend. It only changes the name of that particular number, not how much it's worth. So let's solve 5 and 2/10 divided by 8 on paper together to see how this works. Then we'll take a look at a couple other examples. Okay, so you know by now that you are not going to see questions that always end with a nice, neat, even answer. You know there's probably going to be a remainder somewhere. So let's walk through that 5 and 2/10 divided by 8 together. I'm going to do this one with the box method, but if you prefer the traditional method, you can use that as well. I will show you that in one of our next examples here. So in 5 and 2/10 divided by 8, I'm going to start with my box. I know I'm going to have two columns because I have two digits, the 5 with the decimal point and the 2, and the 8 will go outside. And now before we even start doing the math, we are going to use those decimal divisor or whole number divisor rules. In this case, I'm dividing by a whole number, 8, so I'll bring the decimal point straight up. Because remember, at this point in the problem, you don't know that there's going to be a remainder here, so we're going to place the decimal point right away, even before we start dividing. I can't make a group of 8 out of 5, so I subtract 0, I'm left with 5. I'll bring that up. I know I can make 6 groups of 8 out of 52 things, and 6 times 8 is 48. So when I subtract, I'm left with 4. So here's where normally you might just write R4 and call it a day. But now that we're talking about decimals, we can turn that 4 into a part of a decimal number. And in order to do that, I'm going to add another digit. I'm going to put the digit 0 on the end of my dividend. What I've just done is I've taken 5 and 2/10 and I turned it into 5 and 20 hundredths, which I know is exactly the same value. It just has a different name. We learned way back at the beginning of our decimals units that we could add a placeholder 0 and it doesn't change the value of the number, just the name of it. So by adding that digit 0, I can bring up this 4 and see if I can make another full group, which in this case, I can make 5 full groups of 8 to get 40. So when I put the digit 5 in, 5 times 8 is exactly 40. I subtract, and now I'm left with 0. I don't have a remainder anymore. So I turned that remainder of 4 into 5 extra hundredths, which made my quotient 0 and 65 hundredths. So adding that placeholder 0 gives us the ability to get rid of this remainder. Let's take a look at another example. This time I'll divide 23 and 7/10 by 6 using the traditional method. So I have my 6 out front and I have my 23 and 7/10. Again, since I'm dividing by a whole number, I'll bring the decimal point straight up in my quotient. Now, I can't make a group of 6 out of 2 things, but I can make 3 groups of 6 out of 23. 3 times 6 is 18. So I subtract, I'm left with 5. I'll bring down the 7. I know that 6 times 9 is 54. So I'll subtract 54 things, and I'm left with 3. But now I have a remainder, but I have no more digits to solve in my dividend. So I'll add that placeholder 0. What I just did was I made 23 and 7/10 into 23 and 70 hundredths, which is exactly the same. Then I can bring down that 0. So now I have to divide 30 by 6. I know that I can make 5 groups of 6 out of 30 things. I subtract 30 and I'm left with 0, which means my final quotient is 3 and 95/100ths. So adding that placeholder 0 gave me the ability to get rid of that remainder. Let's do one more together. I'm going to do 30 divided by 0 and 8/10ths, and I'm going to do this one using the box method. So I'll slide this down a little because I ran out of space there. So I have 2 boxes, 30, and I have 0 and 8/10ths. Now, this time I have a decimal divisor, which means I need to shift the decimal point 1 place value position to make that 8/10ths into a whole number. But I don't have any decimals in my number right here. That means I need to remember that every whole number has a decimal on the end. So right away, I'm starting by adding an extra box because I need to shift that decimal point. So now it's like I'm doing 300 divided by 8. Can't make a group of 8 out of 3, so I'll subtract away 0 pieces, which leaves me with 3. I can't make a group of 8 out of 30 evenly, but I can do 3 groups of 8, which is 24. Subtract, I'm left with 6. I'll bring up the 6. Now I need to figure out how many groups of 8 can fit into 60. Well, I know I have 7 groups, which would give me 56. Subtract, I'm left with 4. Now I still have a remainder. I can still use that same rule of adding a placeholder 0 and bring up the 4. Now I know that I can make 5 groups of 8 out of 40. Subtract. I'm left with 0, which means my final answer is 37 and 5/10ths. So sometimes you'll need to add a placeholder 0 because of shifting the decimal point and a placeholder 0 because of having a remainder. So be on the lookout for questions like that. Now I do want to show you one more example that's a 6th grade stretch. So if you're looking for a 6th grade stretch, let's take a look at this example. Okay, in this particular example, we want to divide 3 by 9, and that looks like 2 whole numbers to me. But we are going to find that this is actually going to give us a decimal answer because my dividend, my 3, is less than my divisor, my 9. So I'm going to do this using the traditional method. So I'm going to have my 3 on the inside and my 9 on the outside. Now, since I'm dividing by a whole number, I need to bring my decimal point straight up. But remember, I don't have a decimal point, so I'm going to write it on because every whole number has a decimal on the end. So I'll bring that straight up. Now, I can't make a group of 9 out of 3. So I'll put a 0. I'll subtract 0. I'm left with 3. So right away, it tells you it didn't really help you much because I still have a remainder of 3. So I'm going to put in a placeholder 0, bring that down. Now I have 30 things. I can make 3 groups of 9 out of 30. 3 times 9 is 27. So I subtract, I'm left with 3. I still have a remainder, so I'm going to add another placeholder 0. Bring it straight down. And I get 30. I can make 3 groups of 9, which is 27. Subtract, and I'm left with 3. Hopefully you're starting to notice a pattern. Let me put another placeholder 0. Bring it down. I have 30. I can make 3 groups of 9, which is 27. Subtract, and I'm left with 3. Okay, now I could keep going on and on and on, but hopefully you've realized that no matter what happens, I'm always going to end up with this remainder of 3. When you keep getting the same remainder, it means you have something called a repeating decimal. That means that no matter what I do, that digit 3 is going to repeat over and over and over again. So to show that you have a repeating decimal and that you're not just giving up on the problem, we're going to draw a straight line over the digit that repeats. So that means when we write our final answer to this question, we would write it as 0 and 333 thousandths repeating, so that the person who's looking at our paper knows that we realize this 3 is going to keep happening over and over and over and over again, and it doesn't just end in the thousandths place. So again, that particular question is a 6th grade stretch example, but you will see questions where you have remainders that you need to add a placeholder 0 and use that remainder to solve for an extra decimal place. Thanks for watching, and I can't wait to do more practice of these with you.